Hello and welcome to another mathematics video. I'm going to talk about dispersion measures. So quite simply, if I have the following values here, I can calculate the mean and the median, and hey, what's wrong? They're exactly the same. But clearly the data themselves are not the same. These ones are quite further away. Imagine their IB scores. 3 students get a 1, 3 students get a 7, and this one's here. Now, of course, the mean is very bad and nobody's very happy with these scores no matter what, but clearly these are closer to each other than these ones. So this can be important. People do really care. Like, is there difference in wealth in this country? Are there differences between like the very good students and the very bad students? What's going on with that? So that's why we have dispersion measures, to realize how big the distance is between the values. Now, these dispersion measures, we're going to be looking at 3, and there's like small amplification of one of them. The first one is going to be the range. It means take the biggest value and subtract the smallest value. Here you have some list of numbers. Biggest value here is 587 minus 1, 586. Biggest value here is 24. Careful, the note in order, minus 10 gives me 34. And here the range is going to be 510. It's very simple, but easy to forget. Very simple to calculate, little information. Quartiles are going to be more tricky. So it's going to be the median of the halves. Whoa, what do you mean there? So here I have some values and I calculate the median, so I divide it in 2. I'm going to discard 37, but I get here 2 halves. 1 half, second half. So I calculate the median of each of the halves. And I'm going to get quartile 1, also called the lower quartile, quartile 3, also called the upper quartile. And those are the quartiles. Make sure the numbers are in order. Here I have another list with the numbers not in order. So first I'm going to put them in order. There you go. Now I can calculate the halves. Make sure, here's the one small thing. If I calculated the median, it would be minus 2.5. And I would use both of these numbers, but that doesn't mean that they're not in their own halves. They are. So the quartile 1 will be minus 5 and quartile 3 would be 2. Fantastic. So that's how you calculate quartiles. We're going to do something with them though. They're useful and easy, but do not consider all the data. Realize they're not considering all the data, like the median. What do we do with something called the interquartile range? So I have this list of numbers here. I calculate my quartiles, and if I subtract quartile 3 minus quartile 1, I get something called the interquartile range, which in this case would be 21. This formula up here is actually available in your formula booklet, so in case you happen to forget this, just look it up. Here I have another example. What's the interquartile range would be 7. Now Q2, you might have a Q1, I have Q3. So what's going on with Q2? Do I have Q2? Does Q2 exist? Yes, it does. It's simply the median. If they ever ask for Q2, they are just trying to trick you. Yes, they want to know the median. So this is useful and easy. They love asking this in an exam, but that's what you should know about interquartile range. They do not consider all the data again, so that's the only disadvantage that it has. Now, a small quick example. Here I have some data. First of all, I have to make sure, if I'm going to calculate interquartile range, that they are in the correct order. Now I do that. I divide it into 2 halves. I calculate the median of each half. Realize that I'm going to have the same problem that if I was calculating the median of an even number of numbers. So the quartile 1 is going to be 110.5, quartile 3 is going to be 141.5. When I subtract, I got my interquartile range to be 31. Wonderful. And now we go to the big dispersion measure, the one that really matters, the one that everybody loves, the one that everybody uses, standard deviation. And also, of course, the cousin, the variance, which is not that important for you. But the standard deviation is important in this world, and I'm going to explain to you how you're going to calculate, and you're going to like it because we're just going to use the calculator. Great. So there are 2 types of standard deviation, the population standard deviation and the sample standard deviation. Population is when they've given us all the data, when I have everybody taken into account. If I'm calculating something about the population of a town, I've asked everybody in the town, absolutely everybody, I use the population standard deviation. When I only asked a few of the people around, because I couldn't get to ask everybody because there are 5 million people there, so I use the sample standard deviation. Important just to realize and read the exercise carefully to realize whether you have everybody or just a sample. That's going to determine which one you're going to use. But hold on, what are you talking about? Well, let me explain it to you. Be patient, please. The variance is going to be these things squared. So all you have to know is that if you take the standard deviation or the sample standard deviation that you've just calculated and they want to know the variance, all you have to do is square that number. Fantastic. So here are the ways of all the sofas in the sofa shop again. How do I calculate the standard deviation? You're going to use the calculator. But which one should I use? Population or sample? Well, it says all the sofas in the sofa shop, so I use population standard deviation. And again, to calculate the variance, all I have to do is square it. And here you have sample of minimum temperatures in French cities. So which one do I use, sample or population? Well, you're going to use sample because it says sample here. So I use my sample standard deviation and I square it, and I get the variance. Wonderful. This is perfect. Only trouble is we're going to need the calculator. Okay, but please let me know how to calculate this. Go back to the sofa example. Here you have it. I press in my graphic display calculator, I press stat, then I press edit, and this is what I have. Wonderful. So I introduce the data, be patient, tap it in, 21, 21, 25, 29, 33, and so on. I'm not going to do it for you because it will take this video forever. But once you have it, you press stat again, press the right arrow and enter the calc menu. This is what the calc menu looks like. If we press enter here, you're going to be choosing one of our stats, which is exactly what you have to do. And this is what you will be able to see. Now, for list, make sure you choose the same list that you enter the data in. Normally, it will be L1. And for frequency list, put the frequency list if you have a frequency list. In this case, we don't, but sometimes you will. So we don't have to put anything here right now. Then click on calculate, and this is what you see. And hey, what do we have here? Here we have a sample standard deviation calculated and a population standard deviation calculator. The calculator will always give us both. And quite simply, all we have to do is read the problem again, make sure we have the right one, and we will have the final solution. So that's how you calculate standard deviation. So here's another example of this. They give us this data here, and first they have an X in there and have to calculate into quartile range. If you read the problem carefully, you realize first of all it's telling you a complete set of data. So hold on, that means population standard deviation, and it's in the correct order. So it means that X is the one, it's in the right place here. If I calculate the interquartile range, I realize that 7 is the median, and I have 3 on each half. So the median of this half is going to be 10, and the median of this half is going to be X. So if interquartile range is Q3 minus Q1, Q3 is 10 and Q1 is X, then 5, which is interquartile range, is 10 minus X, hence X will be equal to 5. There you go. And to calculate the standard deviation, I just have to realize that I have to use the population standard deviation, tap the numbers in, and find the population standard deviation, which again, I remind you, tells me how far are things from the mean. Great, so that's basically it. Here's a slide reminding you how to calculate things, what each one of these things mean. And that's all you need to know. Thank you very much for watching. I'll see you next time. Bye.